Hello, everyone. Thanks for joining us at Couchbase Connect this year. And this talk is going to be about test containers. So we're going to talk about how you can trust your tests with proper integration testing for the JVM using test containers for Java and the integration with Couchbase. With me today is Kevin Wittek, software engineer at Atomic Jar and one of the maintainers of the Testcontainers Project. And he's going to give an introduction about test containers. And then my name is Michael Litschinger. I'm a software architect for Couchbase, and I'll be showing you how we integrate Couchbase into test containers. And I'll give you a demo so that you can see how it works in practice, integrating with JUnit and all the bells and whistles that you need for your everyday setup. Now I'll turn it over to Kevin, and Kevin is going to give an introduction into test containers.
Yeah, thank you, Michael, for the nice introduction, and I'm happy to join you in this session today. And I'm here with you actually right now from Istanbul, and Istanbul is not the most silent city actually, so I hope we will have a silent enough session while I'm presenting here to you. And we will talk, and I will talk specifically about test containers, so therefore about testing and integration testing specifically. And for this topic, it makes sense to go a little bit back on the background and on to the definitions. What are integration tests? What are unit tests? And if we think about testing and unit test, integration tests, many of us might think about this testing pyramid, this more or less classical testing pyramid. And I like to show and demonstrate and talk about this pyramid in my talks and my test containers talks quite often. But I just recently wondered, where does this pyramid actually come from? Where does it originate? How old is it? And after digging a little bit deeper, and now I will sometimes look onto the left to my notes to get the dates correct, I found that it more or less officially originated in a book from Mike Cohn from 2009, Succeeding with Agile. And Mike Cohn is, of course, well known from the Agile community for his work on user stories and also on testing. And if you dig a little bit deeper, there is some mythology, or however you might call it, that the pyramid was first described by Mike in a conversation with Lisa Crispin at some Scrum conference or something around 2003. At least that's what Martin Fowler says in the book. And at the same time, you find a different source of the testing pyramid. From 2006 is a hand drawing from 2006 from Jason Huggins. Jason Huggins is the original developer of Selenium, and he envisioned a similar testing pyramid. Okay, so this out of the way, we see it's not that old actually to say it's a canonical truth of software development maybe. But what does it tell us? So it says our test suite might be good to follow this shape, to have a lot of unit tests at the bottom, then some less integration tests, and then some, we now like to call them integrated tests or end-to-end tests or functional tests or UI tests or whatever at the top. And the shape of the pyramid going from down to the top more or less brings a higher test duration. So the tests at the top take longer and are generally less stable, less robust. At least that's how we historically think of this. Therefore, we want to have more unit tests if you want to have a stable and good and nice test suite with a fast feedback cycle. So this version of the pyramid I show here, I have taken from a blog post from Spotify from 2018. And why did Spotify blog post about this? Because Spotify says they themselves are not following the testing pyramid shape anymore nowadays. Instead, they use something they call Testing Honeycomb. Okay, and this Testing Honeycomb is very well suited specifically for testing microservices. And it differs in the following points. So we have some tests at the bottom. They call them here implementation detail, but it's what we would call classically unit tests. Then we have many, many more integration tests. Most of the tests are integration tests. And then we have some of the integrated tests at the top. So now in both of these slides, in this slide and in this slide, the pyramid and this honeycomb, which I took from the Spotify blog post, the top is not called UI or end-to-end test, it's called integrated test. Why is it like this? Integrated test is a definition, meaning a test that will fail of a criteria outside of our own code or our own test suite. So integrated tests are more or less a bad practice, something you want to avoid. And if we think about classical integration tests, these are actually, by this definition, something we would consider integrated tests. So an integrated test is, for example, when I have to make sure my database is running before I run my test. My test will fail if the database was not running. But by this modern definition, if my test itself setups my test environment, makes sure my test environment is there, it is a modern and better integration test. And by going a little bit to this definition and having more stable and better maintainable integration test, it might make sense to rethink the classical pyramid shape and have something that looks like a honeycomb. Maybe. Depends also on the architecture. If you have many microservices, they tend to have a lot of integration surface, then a honeycomb might make more sense than a pyramid that might be better suited for a monolithic application. Okay, so now why do we start to use containers, Docker containers, and then ultimately test containers as a tool for integration testing? So easily we want to have an easy setup of the development environment and the test environment. And nowadays we use tools like test-driven development and so on, practices like these. I would say the development consists also of a testing environment at the same time. And we want to be able to onboard a new project, onboard a new team, just clone the repository and run the test without following extensive instructions on some Wikipedia page or whatever internal wiki pages that tells you, okay, you have to install this database, make sure to import the schema, configure it like this, and the wiki page is probably out of date, you will miss something, and then you will end up your first days in the new project just trying to get the development environment working. So we want to avoid this. We want to follow maybe something like an infrastructure as code approach where everything is already encoded into our project. Then we want to have a parity between our different environments in which we build and test and run our applications. So what do I mean specifically with this? If we use certain CI pipeline tools, for example, Travis CI or GitLab CI, they often provide a way that you define the components you want to integration test against in your pipeline. So for example, you could probably say also for a Couchbase, I want to have a Couchbase in this step in the pipeline. Or you could say the same with Postgres or whatever, it doesn't matter. And then GitLab or whatever tool you're using will spin it up and you have to integrate with it, against it, have to integrate against it, test against it. But this will differ from when you run locally, because locally you're not using the pipeline to execute your test. You're using Gradle, you're using Maven, you're using IntelliJ, whatever. So it makes more sense to use the same mechanism to set up those environments in all those different stages, so to say. And if we do it like this, our whole setup will become self-contained and portable, run the same way in all environments. And yes, then ideally we end up in a situation where no manual installation and setup of external software is necessary when you start in a new project. Of course, some things will still be necessary, like you will have, in this case, Docker. You need to have Docker installed, Java, maybe whatever. But also this tends to change currently with the movement towards cloud IDEs. So now let's look into test containers and the test containers Java library and how it looks. In a nutshell, we can say test containers is an object-oriented API for instrumenting and interacting with Docker containers. And we see here just the basic usage of this API and of this library. We can define Docker containers as objects. Here in this case, I say I want to have a new generic container. Generic container is just wrapping any kind of Docker image, basically. In this case, I just throw in a Redis just for fun. Why not? So I instantiate a new container. I say which image it should be based on. And here's some sounds in the background. Maybe you heard them, maybe not. And then I can configure it a little bit more. In this case, I want to say I want to interact with this exposed port of the container. Then I call start. This will start it. And then I have some additional getters and other stuff. So now the start is already interesting because the start in this case is different than running a Docker run command, for example. A Docker run command will exit or return basically when the container is running. Test containers, however, tries to be application aware, tries to be aware of the application running inside the container. So it will actually do a blocking synchronous call and wait until the until the application inside the container is really ready. It's ready to be interacted with it. How does it do it? So there are different waiting strategies included, and the most simple one will just check that the port is reachable. So in this case, the port 6379. So yes, okay. So this is the first nice feature. So we like this, we can make sure that our system under test is really ready to be tested against. Then another thing we see here, we see the calls Redis get host, Redis get first map port. So in this case, we are accessing the dynamically mapped port. So we specified we want to interact with port 6379, but it is not a good practice to map a fixed port. We could, of course, say we always want to interact with the container on the same port. But what would happen if this port is already in use for whatever reason? Maybe I'm parallelizing my test. Then my test would fail, and that's not cool. Then I have an integrated test again. So instead, what Testcontainers does, it uses the Docker publish port feature. This will just map it on a free port, and then it provides an API that you get the actual map port after the container has started. Similar thing with the call to get host. Testcontainers actually supports running Docker anywhere. It doesn't have to be necessarily on your machine. It can be on some server somewhere, or it can be a virtual machine, whatever. And this is especially interesting if you run a CI environment. You can't always be sure that Docker is really running on the same machine as the one that is executing your tests. Therefore, we have this get host method that will give you the IP address under which the container is reachable, and then you can construct a specific URL like this and interact with it. Then finally, after your test is done, you can call stop. It will stop it. It will remove it, clean up all the resources, and everything is well. Okay, some background information about the Testcontainers project. It has, as Testcontainers Java, been first released in 2015, and it is 100% open source software under the MIT license. We have currently 3 core maintainers: Richard North, who is the original developer, Sergey Egorov, who joined as the second core maintainer, and then me, Kevin Wittek, that joined as the third maintainer. And in addition to the Testcontainers Java version, which is by far the biggest, most used, and most stable feature complete version, we have different implementations in other languages, such as Python, C#, Go, JavaScript, Rust, and they don't share actually any code with the Testcontainers Java version, but they try to align themselves with the same philosophies and the same concept, the same approaches. So some of the features that Testcontainers provides, we've already seen there is support for generic Docker containers. So basically anything that has a Docker image can be used to interact with it in your test and just spin up a generic container. Then we have special support for databases, all kind of classical relational databases, NoSQL databases, and also systems like stream processing, so something like Kafka or Apache Pulsar. And what do these specific modules bring? They are providing pre-configured classes or objects, so to say. So it will already know which port to expose, on which indicator to wait for. So for example, in this generic container example we had before with Redis, we just knew it will wait for the port to be ready. But some applications are more involved, and then those modules configure a wait strategy that will wait for a certain indicator in the application to become ready. We have modules for the different cloud systems, AWS, Google Cloud, Azure, that allow containers of their cloud mock instances. Then we have special support for Docker Compose. So if you already have an existing Docker Compose file, you can just use it. You can point test containers to it and it will use it. And then special support for Selenium that will run the browsers inside the container in a more or less headless version. It's not really headless because it will still render everything in a virtual frame buffer, also allowing you to record the session using VNC and then having a video recording. But yeah, you can run it on a server or whatever. And then support for chaos testing. That is very exciting. Chaos testing is a concept where you try to introduce certain failure scenarios in your test and just want to see what happens, how resilient is your system. And we have support for ToxiProxy. ToxiProxy is a basically TCP proxy you can put between your components, between your containers, and it can simulate things like dropped packets on the network or latency and jitter and all those kind of things. And you can do nice things like what happens if your database suddenly disconnects but then comes up again, so on the network layer, and you can test those kind of things very nicely. Okay, and then some of the more general features that the Test Containers core library provides. And we've seen them in the example, basically. So the one thing is the dynamic port binding, meaning test containers, by the means of the features that Docker already provides, will just publish the port on a free port, and then you have an API to access the actually map port. Then wait strategies. I mentioned before, the trivial wait strategy will wait for the TCP port to accept connections, but we have more involved ones. For example, waiting for certain log messages or waiting for a certain JDBC connection result. Yeah? Then you can basically run using JDBC and SQL query and wait for a certain response. Or another one that's very useful is HTTP wait strategy that just checks that a certain HTTP response gets returned from the container. Test containers works out of the box. You just include it as a Java dependency, and if you have Docker available in your environment, it will automatically discover it and configure itself to interact with it. So it will work with Docker machine. It will work if you have a Docker host environment variable configured, and then also with the classic Docker desktop distributions, meaning Docker for Mac and Docker for Windows, and of course the native Docker Linux installation. So this makes it then ultimately platform independent, and we support specifically Linux, Mac OS, and Windows 10. And on Windows 10 we even support named pipe, so interaction with Docker using the named pipes, which is the Windows way to interact with the Docker daemon, at least from Windows processes. So you don't have to configure anything in your Docker desktop to make test containers play nice with it. So before, some years ago, many applications on Windows needed the Docker daemon to expose the TCP socket. This is not necessary anymore. And it works with Windows 10 normally, but also inside WSL2, for example, and with the WSL backend. Besides the general usage, direct usage using the object-oriented API and calling start and stop, there are also test framework integrations. For example, here we see the JUnit-Jupiter integration, and this means that the test framework will instrument your containers by basically starting and stopping them before your tests, so before each test method, for example, or before all test methods in a test class. This can be sometimes very convenient, but you should be careful because starting and stopping a container, while so much faster than starting and stopping a virtual machine, for example, still has considerable overhead and is comparably expensive. So in general, it would be better if you use the same containers for the same container for all the tests in your test suite, if you can do it. So meaning if you want to avoid test pollution, for example, it might be better to avoid test pollution on a logical level instead of replacing your test infrastructure for every test. Logical level means maybe cleaning the schema, cleaning up the data you've written or whatever. Okay, and a little bit to the current state of the architecture in test containers, which is nice to know and explains some maybe more legacy aspects of the architecture. So we have the test containers core that provides all the basic functionalities, generic container support, the interactions with Docker, and now an important fact, for historic reason, JUnit 4 support is built into the core at the moment. So that means if you're using test containers, you will pull in the JUnit 4 dependency. You don't have to use it, but it will pull it in. Now, moving ahead, we started to extract certain functionalities in modules and other components. For example, other test frameworks are implemented in modules. For example, the support for JUnit-Jupiter or something like Spock. And then support for specific applications that can be run in a container are also their own modules. This is the current state. It might change in future versions of test containers, but this is an important thing to know. And in addition, it's important to know that test containers conceptually still assumes you want to use it for testing use cases, because ultimately test containers will clean up all its resources after the JVM process exits. So that's just something to know. For example, if you want to, for debugging, look into a container or whatever, once your JVM process exits, test container has a mechanism to clean up all its resources. And that's it from my side for a general test containers overview. And now back to Michael for some more Couchbase specific integrations.
Thanks, Kevin, for this great introduction into test containers. So now that you know all the basics of how test containers works in integration with Docker, we're going to focus on how Couchbase integrates into test containers itself and how you can make the best of it. And then we'll end with a demo. So there are a couple of highlights that I want to mention up front how we integrate Couchbase into test containers. The first important thing is that what the Couchbase integration gives you is actually taking a raw Couchbase Docker image and completely provisioning it into a setup that you can use for your testing. That includes buckets, indexes, all the different services, etc. And one of the things that's really cool about one of the latest releases that we did is you can use test containers Java with all the different SDKs that we provide. So it doesn't matter if you're still on our Java SDK 2.x series, or if you already migrated to the newer 3.x series, you can use it with both versions. And you can also use it with the Scala SDK, and you can use it also with our new Kotlin SDK, which is currently in preview. And we did that because the initial versions of the integration were based on the Java SDK 2. But as we released the third version, we found that both don't work well in the same JVM. And to give you the option of using whatever you want, any kind of SDK, we removed all the SDK-specific functionality. It's completely standalone. And again, you can use it with any SDK that you have in your application. It's very customizable. So you can provide custom credentials. You can create custom buckets. You can specifically define which services you want. So if it's just key value, or if you also want the query service, for example, you specify that, and the integration is going to provision everything and give you a container ready for your integration testing. So how do we get from a raw, bare bones Docker container to a fully built and ready to run Couchbase container? So the way it works is Test Containers provides a couple of hooks where the actual integrations can hook into. And there are two that we are going to talk about in this session. One is container starting, and the other one is after the container has started. So when the container starts, there are a couple of things we need to do internally to get the environment up and running. The first thing we need to make sure is that the node is actually online. So maybe you know that Couchbase provides a REST API as part of its 8091 port, which can be used to get all kinds of advanced information functionality. And we are using that so that we wait until the node, that the service basically starts, right? So you can imagine typing start service on your shell, and then the server boots. And then once it's ready to accept any kinds of requests, at the next stage, we are going to check if you're using the community or the enterprise edition. That's important because some functionality is only available in the enterprise edition. And the code makes sure that you can only use those services that you bootstrapped into. From a container perspective, both are available, but of course you want to make sure that if you run your production system against the community version, you want to test with the community version, and vice versa. If you're using the enterprise edition, you want to test against the enterprise edition. And then we need to do a couple of internal things, renaming the node and initializing the alternate address support. Because with Docker, it's a little bit more complicated to get the networking set up right. We do all of that for you in this stage. And then once the networking is set up, we're going to initialize the services. So depending on what you've configured, we are going to initialize key value, query, etc., make all of that available. Then we're going to configure the admin user. We're going to configure external ports so that all the services that you've configured are actually available from outside the container when you connect with the SDK. And then once that's configured, we are configuring the indexer. And how the indexer is configured depends on the Community Edition and the Enterprise Edition. So that's all handled for you. And then at this point, we have a fully functioning Couchbase single node cluster that runs in your Docker container. But usually you also want buckets, right? Because in buckets and now with 7.0 with scopes and collections, that's where your data gets stored. So as a next step, once the container is started, we also handle creating the buckets and the associated infrastructure. So for example, if you've added the query service and you've created a bucket, we are going to create a primary index for you, and you can disable it if you don't want to, but usually that's a great way to get started. And then immediately you can run legal queries against that bucket. So here is a quick example where you can see how we integrate, and this is not using JUnit, so this is basically using a raw version. This is why you see that db.start and db.stop at the end. In the demo, in a couple of minutes, you'll see how that makes it even better with JUnit. So we're going to create a new Couchbase container, and we give it a Docker image name of Couchbase/server. If you don't specify a tag, so a version, it's going to assume the latest one. So at the time of recording, this would be 7.01. But you can specify any version. So if you're still running on 6.6 or 6.5, you specify that, and it will automatically pull that version from Docker. And next, we are creating a bucket. So we say with bucket, and then we give it a bucket definition. The name of the bucket is my bucket, and we specify a custom quota of 150 megabytes. By default, if you don't specify quota, it's going to use 100 megabytes, which is usually enough for testing. But of course, if you have special needs, you can customize that. And in our example here, we are only enabling the key value service. By default, key value query and others are available. But if for your use case, you only need key value, you can specify that as well. You really want to make sure that your integration testing setup mimics your production setup as much as possible to get the best coverage. Then we start the container. And then the next step is very important. So you call cluster.connect. So this example is with SDK3. And our connect method expects 3 parameters: a connection string, a username, and a password. And you get all of those automatically out of the Couchbase container. You just grab them with getter methods. And at this point, you're just doing your regular ops. So you can open a bucket, you can open a collection, and then you run your operation. So you're doing an upsert, you can do a get, etc. And then finally, when you're done, we are stopping the container. So that's what's currently available, but of course, it's not where we're stopping. So there is future work ahead. So for example, what we are working on is allowing you to configure scopes and collections with 7.0. Right now, you can already do this, but you'd have to use the SDK3 management APIs that we provide as part of the SDK to do it. But we are actually integrating it into test containers itself so that you can create scopes and collections the same way you would create a bucket definition. Also making importing sample buckets easier. Couchbase provides travel sample, bucket sample, different bucket types. And while you can import them manually, it's great for demo purposes that you can actually import those sample buckets and then work with them. Also in plan is allowing to configure memory quotas of different services. Right now we stick with the defaults. It will also be possible to add role-based access controlled users. Right now you're basically working off of the administrative user if you're not creating them on your own. And also investigating advanced features that test containers itself provide, like reuse support. So there are so many things we're working on and integrating. We are actively trying to make the system even better. So if you have specific requirements that are currently not covered, let us know, file an issue on the Test Containers Java issue tracker, and we'll make sure to follow up on it. So with that, let me jump into a quick demo so that you can see how it works in practice. Okay, so now we are in IntelliJ, and I'm going to show you how to use it with Couchbase Server 6.6, so without collections, and 7.01 with collections. Now, the first thing you'll see here is when you look at this file is that in the slide that you've seen, we manually started and stopped the container. Now here we are using the JUnit integration, which makes it even easier. So we are using the test containers annotation and the container annotation, which will automatically start and stop. our container. It will take care of that for us. The only thing we need to do is basically have a before all and after all where we initialize our SDK itself, but we can directly work with our Couchbase container where we're using Couchbase Server 662 and my bucket. And if we run this, let me run this while I'll explain what's going on. So we're running a couple tests here. The first one is very simple. We are running key value upsert and get. So we store a document and then we retrieve the document afterwards. And then there is another operation that is a little more advanced. So what we'll do is we'll basically create two documents via the key value service with different document IDs. So they're UIDs, so we don't know what they are in this case. We'll just store them. And then we're going to run a nickel query. So basically we select the ID and the data from our bucket where type equals user. And we specify a scan consistency of request plus, which will make sure that we read our own writes. By default, Couchbase queries are eventually consistent, but you can provide a different scan consistency so that we make sure that those documents are immediately available. So if you look through the logs, and I'm at info level here, you can see we are starting our Couchbase server container image, and then you'll see lots of like wait strategies and things going on where our integration makes sure that the container is ready and boots up probably. And what you can also do is you can set a breakpoint somewhere in your code, and then you can actually go to that URL and you get thrown into the Couchbase server UI. So if you want to debug something in the server UI, if you don't know what's going on exactly, you can go there as well. So, and as you can see, the upsert and get operation here, first, we print our result of our mutation operation, and then we fetch the document and we print the content. And then finally, so the second operation runs the inserts both documents. We are not printing the results there, but what we're doing is we're printing the results of the query. So we're running cluster.query, and the result here are our two documents that are stored on the server. Jumping over to our Couchbase Server 7.0 tests, the only difference here pretty much is that we are going to use 7.01 instead of 6.6. That's the only thing we're changing with the test containers integration. And then, as I mentioned before, right now you cannot create collections and scopes directly from the container definition, but you can always use the collection manager API of the SDK and create the scope and create the collection from there. And then we can create a primary index on our collection, which is done here through a scope.query. And then we're running the same operation that we did from before, but instead of basically using from my bucket where type equals user, we are storing it in a collection. So we can say, run it on our scope and say, select everything from users, basically fetching it directly from our collection. So short and sweet, as you can see, with 2-3 lines of code, you get a fully functional running Couchbase service. It doesn't matter if it's 6.6 or 7.0, and you're off to a great start integration testing with Couchbase and test containers. And with that, thank you very much for your attention. We hope that it was informative and you enjoyed it. And please leave us comments, and we're happy to answer them. Thank you very much.